Recording, here we go. Our handy dandy, where did my PowerPoint go? My PowerPoint left me. There it is. And we left off with frequency distribution. There it is, the M&Ms. We did that, I told you that relative frequency means percentage. There's the relative frequency. And we left off, here we go with a bar graph, and I think I left off there. If not, that's in the other video. But I'm going to start from here because I'm going to do my rant about histograms because there's no difference between a histogram and a bar chart. All right, we good? Everybody can see that? Let me make sure of one thing because they probably already gave up if they were Skyping in. I have a couple of Clemson students in the 120s, and they're Skyping in. I don't think this class is one of them. But hell, they probably already a little bit back to bed. Nope, there's nobody Skyping in. Okay. A histogram, the only difference between this and a histogram, if you squish the purple bars together, that's a histogram. So I want you to put in your notes, I want you to draw this with the purple away from each other, and that's called a bar chart. And then I want you to take and draw a picture with the purple bars touching each other, and that's a histogram. Is there a mathematical difference between the two? No. Does it make somebody sound smarter to say histogram? Yes. So this is a histogram. Make sure you say it like that because you need to sound intelligent. No sneezing in class. Take the sneezing outside, please. It's no fun teaching on Friday. This sucks. Did everybody go here when we had Monday, Friday, Monday, Wednesday? Did you go here?
Yeah.
It was nice, wasn't it?
It wasn't.
But at Tri-County Pendleton campus, if it ain't broke, you do everything you can to try to fix it. It's kind of like the federal government. But you know what a lot of things can be boiled down to? And I'm going to teach you a life lesson here, especially you females. Remember this. Every problem usually can be attributed to one word: control. Everything. If you take all the problems that you've had to deal with, I guarantee it can go down to one thing: control. Hubert, what the heck does that have to do with Pendleton campus? Pendleton campus threw its fit because they were not doing the same thing that we were doing. And what is that called? Control. Think of it like how many of you have had a boyfriend or a girlfriend or both, whichever, had a controlling other person? And when you break away from that control person, what do? They lose their freaking mind. And they don't think, and that's usually when they do what? Do stupid stuff and get thrown in jail. People don't think when they lose control. And that's why Pendleton threw its fit. They did not have control over the other campuses, and they didn't like it. Same thing with, and I'm just using Pendleton as an example. But when you have, and that's why I tell guys not to get married till they're 35 or more older. Women should not get married till they're 20 or older. But honestly, girls, y'all got to watch out for that. Now, why do I not? The guys, you have to watch out for it too. Those Oompa Loompas, orange face and a white neck, you got to watch out for them too because they're cray-cray. They're crazy. All right? And they are controlling too. A woman can be just as controlling as a man. Except they do it, how do I say this? They do it with less physical, okay? They do it with this. Guys, they just stupid. They just do it and get in trouble. I mean, you got to watch that. It's all about control. It's all about control. Tell me I'm wrong. Somebody tell me that that's wrong. It's not. You take any domestic violence, it all goes back to control. And that has nothing to do with purple bars. But if you put them close together, it's a histogram. If you put them apart, it's a bar chart. So a bar chart's redneck, a histogram is flootsy wootsy, hold pinky in the air, like Patrick, putting on airs. I love SpongeBob. I don't like character. I love Squidward and I love Plankton. And I think Patrick ought to be beat with a bat. Okay? Anybody that's stupid, SpongeBob, you can't help but like the guy. And I love Mr. Krabs. When he's real cheap, like the time he had a corporate, remember when he had a corporate picnic? And he put napkins on the ground. What was the entree? Mustard and ketchup, condiments. That was the corporate picnic. I love Mr. Krabs. All right, I guess we gotta keep going. All right, there's the frequency table. Why are we going back to the frequency table? Is this thing going backwards or what? A Pareto chart. I don't even know if I'm pronouncing it right. A Pareto chart is where you put the bars in ascending or descending order. Is it used very much? No. Do I test you on this? No. Do I tell you that it's going to be on a standardized test? Yes. So make sure you know what a Pareto chart is. It is a chart usually in descending order, but it could be in ascending order also. It doesn't tell you very much. Okay? So put Pareto chart, descending order. Your bars are organized in descending order. There you go. The only thing it tells you is which one is the least colors, blue. Besides yellow is my favorite color, but I like brown. My house, when you walk into my house, you got light brown carpet, you got brown furniture, you got brown towels. Okay, I'm brown. I love brown. Don't ask me why. Don't psychoanalyze, okay? But I like brown towels, dark brown. All right? I do not like orange. Why? I just don't. Can you go to Clemson? Yeah. And I'm a Clemson supporter. I'm not a Clemson idiot. Yeah. There's a difference. I've told y'all this, haven't I? No. There's a difference between a supporter and an idiot. I don't name my kids after Clemson University. Y'all, I know somebody that named their kid Clemson. Yeah. They don't live in South Carolina, but they have a child named Clemson. Yeah. Hello, my name's Clemson. I also know another family that painted the inside of their entire house green and purple. Green. These people are freaking crazy. And I'm going to tell you something. I'm going to tell you something socialized or whatever. People don't hate Clemson University. People don't hate Clemson athletics. People don't hate Clemson students. People hate Clemson fanatics. That's why people don't like Clemson. I didn't say supporters. I pay tuition to Clemson University. I paid tuition, 2.5, 2 3/4 degrees to Clemson, and I give to the foundation. I am a A1 supporter of Clemson, but I don't sacrifice live animals or my children. I don't have an altar to Clemson like some of these crazy people. And the craziest people are the people that have never set foot where? On Clemson's campus. Those are the craziest people. So if you're one of those people, I'm sorry, you're crazy. Oh, and you know how I can tell? Whenever Clemson loses a game, whenever they lose, whose fault is it? Everybody. The referees, the stadium, the building, the grass. They're crazy. And you can't have a discussion with them either. Just like I won $300 on this last game. And I didn't make a single bet. They all bet me. Yeah, Clemson going to beat LSU's ass. I said, you want to bet? I'll bet you $100. I said, all right, at least a touchdown. And I won $300. 3 people. If you want to win money, all you got to do is bet a Clemson, not a supporter, but a fan. Because a Clemson fan, a Clemson fanatic, they will bet you no matter if they're playing 5 football teams at one time. They'll bet you $100 that Clemson's going to win. No analytics behind it, no reasoning behind it, no mathematics behind it. Clemson's going to win. Clemson could be playing the San Francisco 49ers and a Clemson fan. Clemson's going to win. Idiot. I'm sorry. Colors of M&Ms. Back to blue. Okay, I'm not going to side-by-side bar graphs. I'm not going to go through that. There's a side-by-side bar graph. I'm not going to test you on that, but you need to know what it looks like. Married, bless their hearts. No, hell no. I'm right here. I'm in the minority down here. No, it doesn't say anywhere on there that I'm married. I made sure of that. Horizontal bars, hardly ever used. They're not used. They're used when you got a lot of categories. And you can make the chart as high as you want to. And they go out to the right. So that's a horizontal bar chart. Very important that you know how to do a pie chart. Okay, let's do an example here. Let's say that there's 1,000 people surveyed. Or let's go with 100. Let's make it simple. 100 people surveyed. Somebody tell me how many are never married. 25. You multiply 0.25 times whatever N is. Okay? So I want you to get your calculators out. And I'm going to put a crazy number up here so y'all can each, well, did y'all see where I put my stylus? Have I written on the board today? No. Okay, then it's over here. Somebody, we have somebody that puts the pins up. Oh, yes. Yeah, there it is. No, that one's dead. Oh, here it is. Yes, we put it up. Yes. All right, here we go. And they have, somebody has, I'm about ready to quit. I think we got it. I think we're cooking with peanut OIL now. So I'm going to say N is equal to 1,537. So let's say you've got 1,537 employees. So I want you to go through and I want you to fill out every one of those. Tell me how many people are married and how many people are not married and how many people are widowed and how many people are divorced. You take each one of those percentages, change it into a decimal, and multiply by 1,537. So make sure you can do that because that's on any, that and a bar chart is going to be on any standardized test, and it'll be on my test. Bar chart and a pie chart. So somebody tell me what 1537 times 0.58 is.
891.
891. Now, if it's a decimal, you're going to round up because there ain't no such thing, or round down. There ain't no such thing as a 0.5 boy, okay, or 0.5 people. So round up, 0.5 or above, round down, 0.4 and below. So 0.06 times 1537.
92.22.
So 92. 0.11 times 1537.
169.
0.25 times 1537.
384.
Now add all those together. And you should get what? Dang old 1537. I don't know why these boxes are coming up when I'm writing. Like I said, around 2050, Tri-County Tech will probably have everything working technology-wise in the classroom. Now, of course, we probably will not be in the classroom by then. We'll probably just all be learning from home, and Tri-County will be working on classrooms to meet. I'm sorry, last 3 years I've been very irritated.
What numbers were it?
I'm trying to get it, hold on. 891. Add them all up, what do you get? It's a miracle. You feel good about yourself? Good. That's a test question. It's a standardized test question. Make sure you can do that. Make sure you can read a bar chart or a histogram. Make sure you can find N, which is adding all the bars up. We did that the other day. Make sure you can do those two things with a bar chart or a pie chart. Now here's an example of how to do this. I'm not going to do this. We're going to do this with something else. I'm not going to do it with these numbers because I like to keep it to around 10 or 15 numbers. This is ridiculous. 1, 2, 3, 4, 5, 50 is ridiculous for a homework question or a test question. Does everybody agree with me on that? So we're going to skip this part. There you go. That's what they did. I want you to be able to do that right there with anything I give you. If you can do that, you can do 2.2. And it's basically tick marks. And then frequency, which is head count, and then percentage. Now remember, percentage, you have to read the what? Directions. They may ask for a percent, they may ask for a fraction, reduced, or they may ask for a decimal. So your directions will tell you how to write the relative frequency. So that's a good example of what you'll see on a test. Here we go with the histogram. And there is a histogram. And like I said before, there is no difference between a histogram and a bar chart mathematically. Okay? The y-axis is the same, the x-axis is the same. The only difference is a histogram, the purple boxes touch each other. I do not test you on a histogram. Now you may have a homework question that has the answer in terms of histogram versus a bar chart, or you may have one that instead of histogram it has a bar chart, instead of a bar chart it has a histogram. I don't care about that. To me they're the same. So I'm not going to sit here and test you which one is a bar chart and which one is a histogram. I'm not going to test you on that because I don't think there's any mathematical difference. Classes. We already talked about classes. Classes are with what kind of data? Quantitative or qualitative? Quantitative, meaning quantity. Remember, boxing, wrestling are divided into classes because you can't divide wrestling and boxers up in blondes, brunettes, and redheads. Okay? Doesn't work that way. And there is your classes. Now you can write this down as an example. Don't write the words. We already covered this. Haven't we? Okay, good. So make sure you write that down because that's a good. Do the actual table. Don't write all that stuff because we already talked about it. So what's 25 from 35? 10. So class width is what? 10. All right, let's go ahead and find the midpoint. What's 25 plus 34? Dang on 59. Half of 59, well, half of 60 is 30. So that's going to be what? 29.5? So that's your midpoint. And then 29.5 plus 10. Wait a minute, that's not right. 25 plus 34 is 59. Half of 59 to, what's half of 50? Somebody take 59 divided by 2. It's supposed to be Okay, it would be. I'm sorry. 29.5. I had a brain bubble there for a minute. I was thinking of class boundary. 29.5 plus 10 is 39.5. 39.5 plus 10 is what? 49.5. 49 plus 10 is 59 points. So there's your midpoints. Now your class boundary. Are these whole numbers or tenths or hundredths? What are they? Whole numbers. So your class boundary is going to be 0.5. So what comes before 25? 24.5. Then add 10. Okay? So 24.5 plus 10 is 34.5 and so on. So everything revolves around the what? The class width. All you got to find is the first one and then add the class width to everything. So let's go over that again, just so you'll have it. You can always watch the video and pause it. 25 plus 25 from 35, or 35 from 45, or 44 from 54 is all 10. So the class width is 10. Now, take 25 plus 34, add it together, and divide by 2. You get 29.5. Now add the 10 to 29.5 and keep going. Third thing, they're all whole numbers, so you're going to take it to the 0.5, which is the 10th, and that would be 24.5, 34.5, 44.5, and 54.5, and those are your class boundaries.
What does class boundary do?
This is something they asked you. It's just the number before and after the next. The lower class limit, what's before the lower class limit, and what's after the upper class limit. That's all it is. You don't use it in anything. The only thing that's real important, the class width is important for calculating, but the midpoint is what you're going to use later. Midpoint is going to be called X, and you're going to use that in formulas. We're going to do that later.
Is it always just like 0.5 less?
No, if you have tenths, if that was 25.0 and 34.9, if it was in tenths, then you would go to the hundredth, which would be 0.95. And then if it was to the thousandth, then you go to the 10,000th and so on.
So it'd be 0.005.
No, you do 0.95, 0.955, 0.95555, like that. The only time you go to the 0.5 is at the 10th. Everything else is 0.95, 0.955, 0.995, 0.9995, 0.99995. You just keep going with the 95s. It's really not that big of a deal, okay? Most of the time with our questions, we're just going to go to the 10th. So that means you'll use 0.5 with a whole number and 0.95 with a 10th. Everybody with me? Okay. Next. When is my alarm supposed to go off? I don't know. I want to make sure it's going off. What time's class over?
No.
I'm sorry, what?
No.
Well, my alarm's supposed to go off. I don't think y'all are being very truthful with me. I don't trust any of y'all, especially you, Miss Alexander. It says 10:55.
Yeah, that's what I thought.
Okay, that's not when class is over.
You said 11 o'clock.
Now, let's see. My elevator music goes off.
Hi there.
Hi there.
It's currently 10:55.
Okay, so that means y'all can go into convulsions now.
46 degrees Fahrenheit. Today's high
And I will turn off the handy dandy recorder.